Hello everyone. In this video, I'm gonna solve IBHM Mathematics Paper 2 questions from last year. The duration of this exam is 2 hours. You are allowed to use graphic display calculator and also formal booklets. Let's start Paper 2 questions from last year. Start with section A. The first question is, consider the function f of x equals 11 times square root of x minus 2 times 6 minus 11, where x between 0 and 20. Find the value of FO0, FO20. So you are just gonna write on your GDC FOX 11 square root of x minus 2 times 6 minus 11. F0 is gonna be this constant minus 11, and the other one is FO20. We can find here it's gonna be 11 times square root of 20 square root of 20 minus 2 times 20 minus 11, which is minus 0.81, 1.81, 1.81. Yeah. And the second question, find the two roots of f of x equals 0. So in this case, it's better to draw this function. It's gonna be minus 11. So the root is 1.73. First root is 1.73. And the other root is 17.52. 17.52. And the second question is already asking for the graph of f of x. So I'm gonna throw it. Maybe I need to the point of y-intercept, which is minus 11. Minus 11 is here. You need to mention that. And also this is the maximum point. We don't need to write it in here, but it's below to 5. And also it will turn from 7.56. 7.56 is gonna be from here. And the roots was 1.73 and 17.52. Yeah, it will pass around like this. And don't forget that our domain is between 0 and 20. So the graph is going to until 20 in this case. And maybe check the 20 is going to minus 1.8. So minus 1.8 means almost here. I will draw it again. Yeah, something like this. Question 2, find the coefficient of x to the power of 6 in the expansion of 2 times x minus 5 to the power of 9. So we're going to find the binomial expression of this, which is 9 choose 0 times 2 times 6 to the power of 9 minus 5 to the power of 0 plus 9 choose 1, 2 times 6 to the power of 8 minus 5 to the power of 1. It's going like this, but we are looking for the 6th power of x. In this case, I'm going to write 9 choose 3, 2 times x to the power of 6 minus 5 to the power of 3. So what is 9 choose 3? It is 987 divided by 3 factorial. 987 3 to 1 and 84. So if you multiply 84 and 2 to the power of 6 and minus 5 to the power of 3, 4 times 6 to the power of, 2 to the power of 6 times 5 to the power of 3. 672,000 minus 672,000. The question 3, a discrete random variable x has the following probability distribution. Find the value of k. We know that if you plug in these numbers, the probability of total gonna be 1. For example, probability when x equal 3. Or you can also write directly 3k divided by 20, 5k divided by 20, 8k divided by 20, 11k divided by 20. It's gonna be 1. From here you can write 27k divided by 20 equal 1, k equal 20 divided by 27. Let's also find this. 0.74. And find the expected value. Yeah, expected value is you are multiplying the probability of these numbers by itself. For example, we know that the probability function is, we found the k, 20 divided by 27 times x over 20 means x over 27. In this case, the first value is 3. We will multiply 3 by its probability plus 5 times its probability, 8 times its probability, plus 11 times its probability. From here you can write 9, 25, 64, 121, which is 219 divided by 27, 219 divided by 20 or 27. It is 8.1. Question 4, the following diagram shows the cross section of the roof of a house. The cross section is symmetrical about the vertical line. Draw points A and E. The gradient of BA is 7 over 12. Find the size of the angle BAE, expressing your answer in degrees. So if the gradient of BA is 7 over 12, it means uh, tangent alpha, which is we can also call tangent the angle BAE, is gonna be 12 over 7. The alpha at the opposite of this angle here, which has the gradient 7 over 12. In this case, we are gonna look for inverse of tan. Inverse of tan, 12 over 7 will be our answer. So let's find this. 12 over 7 is going to be 59.74. 59.74. The builder requires the lengths of the size BA and CE. The builder has the following measurements. There's the measurements here and the angles 90 degrees. So we're going to find first CE and BA. To find CE, we need the E, and we know this angle, the tangent of this angle is going to be here, for example, we say 12 tangent alpha, we say 12 over 7. And this line is symmetrical. In this case, this length gonna be 350. So this angle is also same with BAE. So we can use sine alpha to find the E, right? The sine alpha equal 350 divided by DE. In this case, DE will be 350 over sine alpha. So CE equals 50 plus 350 over sine alpha. Let's find this. 50 plus 350 over sine. I'm gonna write the exact value of alpha. Do not make mistake. Was 12 over 7. So it is 455.20. Yeah, now we are finding BA. And to find BA, we need this length. Let's call it N. By the way, you're not allowed to draw this diagram. So we're gonna erase it again. To find BA, I know this length is 30 centimeter, and also tangent alpha. Tangent alpha equals 30 over n. So n equals 30 over tangent alpha. To find B, we're gonna use CE, which is 455 approximately, 0.2 plus 30 divided by tangent alpha, which is 12 over 7. So I will find 455.2 plus 210 divided by 12. 210 divided by 12. This 472.7. Question 5, consider the function h of x equals log base 10 of 4x squared minus r times x plus r minus 1, where x is a real number. Find the possible values of r. So the attribute of logarithm inside of the parentheses needs to be greater than 0. In this case, we can look for discriminant needs to be less than 0. If this quadratics, which has the graph of parabol, has no roots, other words, does not have x intersection, it will always be positive, this quadratics. For this, we choosing discriminant less than 0. So what is discriminant? We will use the coefficient here. For example, ax squared plus b times x plus c. If there is a equation like this, the discriminant equals b squared minus 4 times a times c. For this quadratic, the discriminant is minus r squared minus 4 times 4 times r minus 1 less than 0. R squared minus 16 times r plus 16 less than 0. Actually, we can also draw this by GDC. This is x squared minus 16x plus 60. So 1.07 and 14.93. 1.07, 14.93. We are looking for the sign table, and the sign is starting by positive, positive, negative, and positive. Inequality will be correct. So we're gonna choose R between 1.07 and 14.93. Question 6. A continuous random variable x has probability density function. Here is the function. Find expected value. So the formula of the expected value is in integral. We're gonna write x times f of x, and our limits in here from 0 to 2 plus the other integral is starting from 2 to 8. In this case, we're looking for x times first the function 1 over 5. Don't forget to write the x here from 2 to 8, x times, or you can write directly minus x squared over 30 plus 4 times 6 over 15. X. Let's find this. The first one is easy. You can find it by yourself. X squared over 10, the integral of this function from 0 to 2. You can find in here, it's going to be 2 squared over 10, which is 2 over 5. And the second integral is, you can use calculator. From 2 to 8, and the function is minus x squared over 30 plus 4 times 6 over 15, and the x, it is 2.4. So total, it will be 2 over 5 plus 2.4, which is 0.4 plus 2.4 equals 2.8. The second question is asking for, given that expected value c minus 2 times 6 equals 0, where c is a constant, determine the value of c. So the attribute of this expected value, you can write c minus 2 times expected value of x equals 0. C minus, we already defined it 2.8 and at the previous question. So 2 times 2.8 gonna be 0. And from here, C is 5.6. Find the median of x. We know that the integral of this function gonna be 1 over 2 if you are looking for the median. So you can start 0.2, the integral of 1 over 5 dx plus from 2 to let's say x, because we are looking for the median, it's going to be somewhere between 2 and 8. And the function in here, minus x over 30 plus 4 over 15 dx needs to be 1 over 2, right? So this integral is, we can write x over 5 from 0 to 2 plus integral of this other function is, uh, let's say in parentheses, minus x squared over 60 plus 4 times 6 over 15. It's better to write to the upper limit like a, because it will not be the same with the x here. From 2 to a, here is 2 over 5 minus, in parentheses, 4 times a over 15 minus a square over 60. Now we are plugging 2 into this function and write minus and open a parenthesis to not make a mistake in here. It's gonna be 8 over 15 minus 4 over 60 equal 1 over 2. So in parentheses, or let's write it again. I'm gonna append the page here. 2 over 5 in parentheses, you can write 4a over 15 minus a square over 60 in parentheses minus 28 over 60 equals 1 over 2. And from here you can multiply by 60 everywhere actually. It's gonna be 24 plus 60 times a minus a squared minus 28 equals 30. From here you can write a squared minus 16 times a plus 34 equal 0. And to find this, you can use the calculator. Let's graph it. So 2.5, because this needs to be between 2 and 8. The other solution is out of the range. So it is 2.52. A is 2.52. Question 7. A self-service sushi restaurant has a row of 12 available seats as shown in the following diagram. Henry, Wani, and Parita decide to go to the restaurant for lunch. Find a number of possible ways that they can be seated in this row. They decide not to sit together as a group of three. So we can find the total permutation for 12 people in three seats. And we can subtract from this one uh, the possibility that they can sit together. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibility. In 10 cases, but they can also can change the C's in each other. So I'm writing three permutation of three in C's of three. What is this? The permutation of 12 people in three sets. It is 12 times 11 times 10 minus 10 times 3, 2, 1. Let's calculate this. Minus 60, right? It is 1,260. 1,260. The other question is the next day, Anvi, Wanya, and Paris are joined by three additional people in the same restaurant, and they sit in the same row of 12 available seats. Henry, Wanya, and Parita now decide to sit next to each other as a group of P. Find the number of possible ways that these six people can be seated. Uh, so they decide to sit together, and you know that there are 10 cases, like we calculated at the previous question. For example, if three of them is in the first places, uh, and it means the other people will choose the remaining C's, which is permutation nine people permutation of nine people in three C's times 10 times the number of permutation of three people at three C's. Let's find this. 987 times it was 60, right? 30,240. Question 8, given that W is a complex number, prove that W times conjugate of W equals the magnitude square root of, square of magnitude of W, complex numbers. Yeah, let's prove that first. You can write let W equals A plus B times I. In this case, the conjugate of W gonna be A minus B times I. So if you multiply these complex numbers, it will be A squared minus A times B times I plus A times B times I minus B times I squared, which is A squared, these are cancelled, plus B squared because E squared equals minus 1. And the magnitude of W also square root of A squared plus B squared. So we prove that this is square of the magnitude of W. Given, yeah, the complex number set and W satisfy the following equations. Given that the magnitude of W 2 times square root of 5, find Z expressing your answer in the form this. Let's write it equations here. I will change the color. So what can we do in here? Uh, yeah, from the previous questions, we know that this production of W and conjugate of W. So I will multiply it side by side, which is 5 times Z times W times conjugate of W equals 1 minus 2 times I times 10 plus 10 times I times Z square, is it? Yeah. So we can write 5 times Z. This was the square of magnitude W, which is 2 times square root of 5 square. And you can also multiply here 10 plus 10 times I minus 20 times I minus, it's gonna be 20 because I square is minus 1 times Z square. And you can cancel one of the Z's. 5 times 20 means in parentheses that is 30 minus 10 times I and times Z. Z equals 100 over 30 minus 10 times I, which is 10 over 3 minus I. So if we multiply both sides by 3 plus I, it will 30 plus 10 times I divided by 9 plus 1, which is gonna be 3 plus I. And we found A and B. A is 3, B is 1. Question 9, the sum of the first n terms of a geometric sequence is given by Sn. Given that Sn converges, find the range of possible values of C. So log base 2 of C, the absolute value of this, it's gonna be less than 1. So log base 2 of C gonna be between 1 and minus 1. In other words, we can write both sides base of 2 At the right side, you can write log base 2 of 2 instead of 1. At the left side, you can write log base 2 of 1 over 2 instead of minus 1. From here, you can write C between 1 over 2 and 2. The question be in the case where C equals 1.5, find the least value of n such that, yeah, it's inequality. So let's plug in C into this expression, log base 2 of 1.5 to the power of r. So what is S, the sum of the geometric series if it goes to infinity? You can check the formal booklet and see in here, uh, yeah, this one. It is the first term of this geometric sequence divided by 1 minus the common ratio. So the first term of this geometric sequence is, you can see from here, if you plug in 0, 5 divided by 1 minus the common ratio is log 2, the log base 2 of 1.5. We can find this, or we can also calculate Sn, which is, we can see from here again, from the booklet, U1 is gonna be same, 5 times 1 minus log base 2 of 1.5 to the n to the n divided by 1 minus log 2 base of 1.5. So from here, we're going to use this inequality, absolute value inside 5 over 1 minus log 2 base of 1.5 minus 5 times in parentheses 1 minus log 2 base of 1.5 the power of n divided by 1 minus log 2 base of 1.5 is less than 0.1. Yeah, less than 0.1. In this case, it's gonna be between minus 0.1 and positive 0.1. 5 is a common, and denominator is common also. 5 times 1 minus 1 plus log 2 base of 1.5, the power of n. From here, you can write minus 0.1 uh, 5 times log 2 base of 1.5 to the n less than 0.1. And yeah, let's graph of this. I'm gonna graph of this. 5, to write logarithm, you're gonna use this one, but in calculator, you're not allowed to write the base except 10. So I will show you how to write it. It's gonna be log 1.5 divided by log 2. It's the same. And to the power of n actually. So we can write the power of n or x in here times 5 divided by 1 minus the same in here. Yeah, and it needs to be less than zero point 0.1. Let's check it where. Yeah, as you see that we will choose n 9 and 9 at least. Now we are at section B. The questions in here have the highest mark. At question 10, the following table shows the population of Canada 3 years after the year 2000. Here is a table. A student used linear regression to model the population of Canada using this data. Student model is like this. Write down the value of A and the value of B. So to find the regression linear model, we're gonna use, you can also calculate it on your TI Inspire GDC and 0, 5, 10, 15, 20. X values 0, 5, 10, 15, 20. And the Y values is 30.7, 32.2, 34, 35.7, 37.9. Yeah, let's calculate. So we're gonna write P P equals 0.36, or you can write the exact value is 0.358 times t plus 30.52. Interpret in context the value of A. By the way, A is 0.358 and B is 30.52. So in here you can write uh, alpha represents the rate of increasing in every year. Yeah. Question B. The student used this model to predict the population of Canada in the year 2030, where t equal 30, and calculates a population of approximately 41.3 million people. Comment on the reliability of the student's prediction. This model is useful in this range of data group. Since 30 is not in this group, we can write since 30 is an outlier, uh, The prediction is not reliable. A data scientist Benoit used additional information to develop an exponential model for Canada's future population. In this model, BT echoes like this represents the millions of people in Canada 2 years after the year 2000, where T equals to 25 and 100. Use Benoit's model to predict the population of Canada in the year 2100. We will just plug in 100 into this formula. It's going to be 32.5 times 1.005 to the power of 100, 55.16. You can write. Interpret in context the value 1.05 in Benoit's model. So we can say that the population is increasing by 0.5 percentage every year. Yeah. So that it's continuing like this. Another data scientist, Cecilia, develops a third model for the Canadian population. In this model, CT equals this represents the millions of people in Canada 2 years after the year 2000 the same. So use Cecilia's model to predict the population of Canada in the year 2100. We're gonna do the same. We will just plug in 100 into this expression here. So let's find this. 62 divided by 1 plus 8 to the power of 8 to the power of minus 2. Yeah, because it's gonna be 2. So this is approximately 54.61. 54.61. And determine the year in which the difference between the prediction from Benoit's model and Sicilian models is greatest. So I will take this first. And other one. So you can write both of the functions in here and subtracts from each other. It was like this, or you can also write t in here. I will draw the graph of this. Uh, 32.5 times 1.005 to the power of x minus 62 divided by 1 plus 8 to the power of minus 0.002 times oh 02 times 6. So the graph is like this, and since t between 25 and 100, we will see from here the the difference between each other is gonna be maximum at the point where t is 50, let's say 59, and you need to maybe throw this graphic to prove it. Is coming from the point 5 like this, right? This is 100 and this is let's say 19, and here is gonna be 99. The question, we find the value of the derivative of b at the point 75, derivative of b at the point 75, and the b2 function is here, 33.5 times 1.005 to the power of t, and we need the derivative of this. Actually, in your TIS file, you can find this directly, but I will write first the derivative of this function. It's gonna be 33.5, the same. Just you are adding an 1.005. In this case, we will substitute 75 into this function here. Let's find this. 0.24 approximately. The question 2 of f is asking for the derivative of c. First, I'm writing again the function here, which is 62 divided by 1 minus 8 to the power of minus 0.02 times t. And when we find the derivative of this function, as I told you, like in your TI Inspire, you will directly find the value of this derivative. And I first found the derivative of this function and then calculated at the point 75. It's approximately 0.18 or 0.185. And the question G, compare and interpret in context the values of B prime 75 and C prime 75. As we see from the previous question, B prime 75 is greater than C prime 75. So this means in 2075, the rate of increasing in in Benoit's model, uh, in 2075, the rate of increasing faster in Benoit's model than Cecilia's model. Yeah. A line L is defined by L. This is the Cartesian equation in here. And find the equation of L expressing your answer in the form R equals alpha plus lambda times B. So I'm writing the question A in here. Yeah, let's equal it to the lambda. In this case, minus x over 2 equals lambda minus 1. Minus x equals 2 lambda minus 2. X equals 2 minus 2 lambda. And y equals lambda minus 4. And z equals 3 lambda. In this case, we can write r equals uh, for x, the initial point is 2, for y is minus 4, for z is 0, plus lambda times the coefficient for x minus 2, for y is 1, and for z is 3. At the question B, determine the minimum distance from the origin to the line L. So we know that x equals for L 2 minus 2 lambda, y equals lambda minus 4, and z equals 3 lambda, right? If there is a point on the line, it should be like this. And we know that the origin is 0, 0, 0. In this case, uh, the distance between O and L, we can write like O and L is square root of, it's gonna be 2 minus 2 lambda square plus lambda minus 4 square plus 3 lambda square. Yeah, we are looking for the minimum value of this function, and we can simplify it, but you don't need to write like this. You can also draw the graph. 2 minus 2x to the power of 2 plus lambda, but we are writing the variable x in here, plus 3 lambda square, which is 9 times 6. We can write square. These are in parentheses, and the power of 1 over 2. So we are looking for the minimum value. It is approximately 3.2. 3.93. The minimum value 3.93. Maybe it's better to mention from where you found this value. You can say that I draw the graph of this function and find here 3.93. In the question C, a plane pi is defined by like this. This is the equation of the plane. Verify that pi contains L. So we can write the equation here. 6 times 6 minus 3 times y plus 5 times z equals 24. And L, and we also find the equation of L is here. Let's write it. This one also. We're gonna substitute 2 minus 2 times lambda into the x and lambda minus 4 into the y and plug in to the z 3 lambda, which is 12 minus 12 lambda minus 3 lambda plus 12 plus 15 lambda. So we can cancel here lambda is UC and it equals 24. Yeah, at the last question, a second line M is parallel to pi. The line M passes through the point 412 and intersects the z-axis. Find the equation of M expressing your answer in the form, yeah, like this. So we know that there's a plane and lambda inside of this plane, and the equation of this plane, and there is also M is parallel to this plane. This is M, and we know the point on M, 412, 412, and it's also passed through the z-axis. In this case, there is also another point which is 0, 0, let's say A, since it is on the z-axis. This is L, this is the plane pi. And we know that also equation of the plane 6 times 6 minus 3 times y plus 5 times z equals 24. In this case, the normal of this plane is, let's say, 6 minus 3 and 5. And we know that the direction of the L also. And from here, we can also write the direction of M, which is A first. We're going to subtract each dimensions for x, for example, 0 minus 4, for y, 0 minus 1, and for z, a minus 2, which is minus 4, minus 1, a minus 2. So, and this is direction of M, and we know that the normal of the plane, and these are perpendicular to each other. So we can say that uh, here, these two vector, if you find the scalar product of this vector, is gonna be 0. In this case, minus 24 plus 3 plus 5 times a minus 10 is gonna be 0. 5 times a is gonna be 31, and a is 6.2. So we can write the equation of m, the line vector equation, because we found the direction of m also, which is -4, -1, and 4.2, because a minus 2. In this case, we're gonna write in the form m as equals, it says we can also use this point for the initial point for 1, 2 plus lambda, and then we can also multiply it by 5 actually to make it integer here, which is -4, I mean -20, -5, and 21. This is the last question of paper 2. A curve C has equation and x is a real number and is not equal to the minus k, where k is a real positive constant. Show that derivative of y. And I'm writing again the function here. 2 times x squared plus 6 times x minus 3 over x plus k. And we are looking for the derivative of y in terms of x. Since this is the rational function, we're gonna apply quotient rule of derivative. First, we are finding derivative of the numerator, which is 4 times 6 plus 6 times the denominator, x plus k, minus the numerator, 2 times 6 squared plus 6 times 6 minus 3, and the derivative of the numerator denominator is 1 divided by x plus k squared. So simplify this expression, we will multiply it 4 times x squared plus 4 times xk plus 6 times x plus 6 times k minus 2x squared minus 2 times x plus 3. And from here you can write less 2 times 6 squared. These are cancelled. 4 times 6 times k plus 6 times k plus 3 over x plus k squared. Yeah, perfect. Question B. Find the range of values of k for which a local minimum or maximum point exists. To find the maximum or minimum points of the function, we will find the equation where the derivative of function is 0. To do that, I also know the derivative function. It means the numerator gonna be 0, right? This gonna be 0. To find the roots of this equation, we're gonna check discriminant. So what is discriminant? Let's mention the coefficient here, 4 and k, and this is the constant. So square of 4 times k minus 4 times 2 times 6k plus 3 needs to be greater than 0 to find root. If there is a maximum point or minimum point on the sign table, let's say A and B, it needs to change is sign from, for let's say, increasing to decrease or decreasing to increase. So what's this? 16k square minus 48k minus 24 greater than 0. We can divide it by 8. So 2k square minus 6 times k minus 3 greater than 0. So I will draw this graph. 2 times 6 square minus 6 times 6 minus 3. The zeros of here is minus 0.44 and 3.44. 0.44 and 3.44. So our sign is starting with positive, negative, and positive. So k is a real positive constant. In this case, k needs to be greater than 3.44. Consider the curve C when k equals 2. Write down the equation of the vertical asymptote. So let's think about the curve. 2 times x squared plus 2 times x squared plus 6 times x minus 3 divided by x plus 2. The vertical asymptote is in here. X equals minus 2. This is the vertical asymptote. And the question D, find the equation of the oblique asymptote. Dividing this quadratic to the x plus 2. So there is 2 times 6, and I'm multiplying by x plus 2. 2 times x squared plus 4 times 6. If we subtract each other, it is 2 times 6 minus 3. And we're going to multiply it by 2 again. 2 times 6 plus 4, which is minus 7, the remaining. So in this case, we can write the curve like 2 times 6 plus 2 minus 7 divided x plus 2. So this part, this is the oblique asymptote. It is y equals 2 times 6 plus 2, right? Show that derivative of the curve is greater than 2. Yeah, this is the curve, or we can say y equals times x squared plus 6 times 6 minus 3 divided by x plus 2. And we found the derivative of y. Yeah, it was here. Just we're gonna plug in 2 into the key. 2 times x squared plus 4 times 6 times 2 plus 6 times 2 plus 3 divided by x plus 2 squared. Yeah. And in this case, the derivative of the function is 2 plus x squared plus 8 times 6 plus 15 here, x squared plus 4 times 6 plus 4. We can also write this equation, this fraction, 2 plus Okay, the denominator is gonna be same, and the numerator is gonna be 7. So which is greater than 2, right? Yeah, we show it. And the last question is asking for the sketch the curve. General behavior as it approaches each asymptote. You're not required to find an x-intercepts. Yeah, the graph will pass through from the minus 3 point almost 5. Let's say 1, 2, 3, 4. It will be somewhere here. And the other x-intercept is 0.40, almost half. So it can be from here maybe. And the y-intercept is minus 1.5, somewhere here. And we know that the vertical asymptote is passed through minus 2 x-axis. And the oblique asymptote is, we found it 2 times 6 plus 2. It is minus 1, this is 2. And the graph will not touch these lines because these are asymptotes. It will pass through like this and approach minus 2. And from the other side, it's gonna be something like this, yeah. Yeah, we done paper 2 also, and see you at the paper 3. Thank you for watching.